Okay, so we'll start with the numericals. We know now in our previous class the difference between the series and parallel circuit. So let us start with this one. Example 12.7. This you'll find on page textbook. We'll do slow because it's not hard, okay? Just listen carefully. 223. But it needs some patience. Okay, so here, let me read the question for us. An electric lamp. Okay, the diagram is given there itself. So let us draw the diagram first. Here the diagram is one resistor here, and then electric bulb. We can make it more simple than the textbook. This is allowed. Simple bulb for means lighting equipment like tube light, bulb and all. So this is connected, and then to the battery. One is their cell, then line, long line, short line, line, short line. So 1, 2, 3 and 4. One more. So when only one like this long and short, then that's called a cell that can supply some current. But when we combine more than one, here 2, 3, 4, more than one, we combine 2 or more cell, that is called battery. Purpose is to supply more current, okay, more voltage. Supply. Long line is the positive terminal, short line is the negative terminal. Here each of them have got, according to the question, total voltage. All these 4 cells combined is giving 6 volts. Then let us connect it to a switch. There is a switch, and then the circuit completes. Switch means switch on and off. On means there will be a dot here. And as we discussed in last class, also remember, current flow from positive to terminal to negative. So current will never flow from negative like this, wrong. This is wrong. So from positive means we go here and let the current come out, I. So here comes same current, right? And you know that in series, whatever current pass here will come out here. Through here also I, here also I. Current in series is same because there is only one path. We discussed that in the previous class. So let us go to the question here. As we read the question, we will find that let us put R1. Okay. Calculate total resistance, current through the resistors. Okay. So you can start straight, I think. So just go to B. Yeah, sorry, A. A. Calculate the total resistance. So let RS. I'm putting RS because you see this resistor is connected to the lamp of one after another. So I would know it's series. That's why I'm putting RS. Let RS be the total value of the resistance of the 20 ohm lamp. Lamp means electric bulb. This one. So this is 20 ohms. And this is 4 ohms. And the 4 ohm conductor, which are in series, as you can clearly see from the diagram, which are in series. The question did not tell us these two are connected in series, but by the diagram also we know if they are in parallel, there will be like this one, and the tube light, the light lamp will be below or above, but here after, so we know it's series. Therefore, total resistance formula for when it's series is this one. So we write RS equal to, R1 means simply the first one, so first one is 20 ohms, plus R2 is the second one, so no more, so that is it, 24 ohms. So let us put this one as equation 1. Our first answer done. Now let's go and answer B. The current through the circuit, I is equal to V by R. So here, B. So let I equal to question mark, current, that we have to find current through the circuit, passing through the circuit. If you don't write also, it's okay, through the circuit. Let us go really slow so we get it clearly. Now, in order to get your eye, look at Ohm's law. Basically, we're going to use, we may need this sometimes, but basically we're going to need this 3, 4, 5 only. Okay, so Ohm's law. I we have to find, so V and R we need to know. So let us write down V equal to, already given in a diagram, 6 volt is total potential difference or voltage. Potential difference, or we can also call it as voltage. Okay, so V is there. To find I we need V and R. So, and then we got here RS just now. R is also there. R is simply the total resistance. So here we are using RS. So 24 ohms, as we get this one by using equation number 1. So we know to find I we need just V and R, because we can use Ohm's law. So using Ohm's law, V is equal to I into R, but in our case R is put as RS, so we put RS. So we have to find I. Question number B, current. So next step, just put I on one side and then don't move this V also. Then shift this RS, then into means it will go to the denominator. So that will give you equal to, okay, that will give you equal to, okay, so let us just do spacing. So here V by RS is equal to I, we got that. So as we shift this RS, go down. V just now we got 6 volts, as you can see here. RS we thought, arrange it for ourselves, 24 ohms is equal to I. And we know that you can cancel this one, 6 4s are 24, which means 1 is left here. So 1 divided by 4. So here 1 is less than 4 means we put 0 point, then 1 0. 2s are 8 and 2 remainder. Point means we're allowed to put 1 0 at least. Then 4 how much is 20? Yes, 4 5s are 20. So our answer is I here is equal to this one, 1 divided by 4, 0.25 volt by ohms. Okay, we don't need to memorize, but I'm just saying volt by ohms. You can just go here, it's easier. SI unit of current is ampere, so we just write like that. Number 2. So B also answered. Finally, let us go to C. Potential difference across the lamp and also conductor. So that part we have to solve. So let us go and do it. So this part I think we can wrap it out. So here, let's just keep this part. 24 ohms we'll need later on, so just this part saved. Now here C, to slowly, potential difference across the lamp. Okay, so across the lamp is this one. So let us put here potential difference across the lamp is V1. And also across the conductor. Conductor is this one. So between the 2 points connection of this one is the V2. So we have to find this V1 and V2. So V1, come to question mark, is potential difference across the lamp, which is 20 ohms, as you can clearly see. Then V2 is question mark, same potential difference across the conductor, which is 4 ohms, as you can see here. These two. Now we know that V is equal to V1, V2, so I into R. In the previous class we learned that potential difference across first resistor and second are not same. First and second are not same in series because they are between different points. So let us keep that one in mind. So here, therefore, V1 will be equal to, it will be the same current because in series the same current flows through the whole circuit because there is only one path. We learned that. So I into, and then the total resistance is RS. Oh, sorry, across, not RS. Across what? You have to see V1 is across the lamp. So lamp is, the R is, resistance is ohms, this one. I into R, 20 ohms. Or you can just write once using Ohm's law. Using Ohm's law, V, which one is here, V1 is equal to I is same into R is here, V, R in our case is within put, so directly we can put into 20 ohms. Right, so we can just write here V1 is equal to I into 20 ohms. And let's do it together, it's easier that way I think for this case. V2 will be likewise I. Now both have the same current because they are in series. We know that in series, current through both resistors are same because there is no additional path. But the resistor in this case is the conductor, which is 4 ohms. So we are comparing. The only difference is this 4 ohms, this is 20, otherwise I is same because they are in series. Now we calculate this, then we're going to get, after this, you come here, then V1 will be equal to I. Just now we got here, see 24, not that one, this one here, 0.25 ampere into 20, so 20 ohms. And this one V2 is equal to I is 0.25 ampere into 4 ohms. So we can just simply write here, reason for this one is, since using equation number 2, which has the value for I, 0.25, I replaced by 0.25. So that will be equal to here, 0.25 into, or this 10 you can use to shift the decimal here, then become 2.5. So no more 0, so multiply to 2 is your answer. 10 to plus 1, so 5.0 means 5 volt. This is the voltage across the 20 ohm resistors. Let us say this is equation number 3. Then here, and V2 will be equal to 0.25 into 4 is 100. 25 4s are 100. Forget about the decimal for time being. The 2 decimal means 1, 2. So 1.00, that means simply 1 volt, because the SI unit of potential difference is volt. This is equation number 4. So all the answers solved. So you can finally write the answers one by one. Maybe here. So number A, there, the total resistance of the circuit. So you write here, total resistance, which we have calculated in A by using, you will remember RS. So you write your RS is equal to 24 ohms, since using equation number 1. First answer. Then B is, go back to question, the current through the circuit. So current through this circuit, which we have found out by using I think. Right, so here current through the circuit here, IAC, is equal to, we have found here 0.25 ampere, since using equation number 2. So second answer. Then next, finally, your final answer. Here V1, okay, V1 equal to 5 volts. And like this was there, okay, this is equation number 3. So C is potential difference across electric lamp and conductor. Potential difference across the lamp, which is the 20 ohms one, and conductor, which is the 4 ohms ones, are, you can just write this, and V1 first across the lamp 5 volt, and V2 1 volt, write here respectively. That means this is across the lamp, first one, this is 1 volt is across the conductor, And you can finally write the answer reason here. This one, and you write your things using equations. Here we got V1 equal to 5 volt. This was equation number 3. So equations 3 and 4. So that concludes your question 12.7. Let us go one more question, and then the next 2 questions we can do in the next class, I think. Okay, so yeah. Okay, so next question number 1. Page number 224. Just look at that box where blue color writing. Okay, draw a schematic diagram of the circuit consisting of battery of 3 cells 2 volt each. So there is a 3 cells of 2 volt each. So let's just draw like this. Long line, short line, long line, short line, long line, short line. 3, so I drew 3. Short line after the dash, long line, short line after the dash. So this is the negative terminal. This is the positive long line. They are connected. So each of them 2 volts. So 2 volts, this one. This also 2 volts. This also 2 volts. Like that. Each to a 5 ohm, 8 ohm, 12 ohm resistors, plug key, all in series. So they are connected to one resistance, 5 ohms. Next one is 8 and 12. So 8 ohms. And then 12 ohms. We did like this because they said, see the question, last word, series. So 5 ohms, after that 8, one after another, series. And then it has got a key. Key means switch. So switch, usually textbook is putting this side. So switch means on and off. If there's nothing, means current is switch off, so current is not flowing. If it is dot, is there, switch on, so current flow. Okay, and all connected in series. So suppose you switch on, you have to get the direction of current, correct? So current never flow from negative to, if you draw like this, wrong. Negative to positive is wrong. It will be from positive, so I will come out here. And will pass out. Everywhere it will be same because it is series. So this is your answer. Just the diagram they're asking. Okay, we'll do the next 2 questions here, 2 and 2.8. In the last class, after which you can give the test. Okay.